Now, if placed between two verticals having separation, quotient of friction for one wall is 2 mu, other one is mu. What is the minimum rise in temperature so that rod is in equilibrium? The weight of that will act here. Here given G information. What is the rod? Rod is here. There's a rod. Okay. Okay, let's get into. There's a rod, what we have. Now rise the temperature. What is the minimum rise in temperature? This one. If I rise the temperature, what the rod wants to expand, no? And as the rod expands, it will exert a force. So what are the forces that will be? F, F. I'll write F naught something. What is F naught? Shall we? And prior to this, the weight of the rod will act. Call that is mg. So he has given length made of material having density rho. So how you define mass? Mass equal to density by volume. Where all m is there, I can replace this later. Now, if there's vertical walls were smooth, what will happen to the rod? Due to weight, it will fall. No. So for that not to happen, I will rise the temperature. The rod wants to expand. The walls will not permit. So what should be the delta L? Delta L should be equal to L alpha delta theta. Both the walls are rough. Tell me what actually goes on here. Uh-huh. Okay, this one, mass, density into volume. Okay, thank you. Y has given 2 mu and mu. Okay, let's do one thing. Now go back to the friction concept. You have to take help of friction ideas here. Let me shift it down here. Now what about the friction forces that will be acting? At here, quotient of friction is two mu. Let this be mu. Same friction. So here friction. Let it act like this. F1. Here the friction on the rod. On the wall, we need not to show it. Who will provide that normal contact? The F naught only. Now tell me, like, if F2 is equal to mu F naught. What about F1? F1 will be static. Agree this? Because here, what is the thing? What is the thing like and all? Because this is 2 mu, no? So don't write 2 mu. A static friction will act here. So how much of static friction? So here F1, instead of writing mu F naught, no, better write F2. F2 is what happen is having. So further what will happen? So this is here limiting friction. This will be static here. Here if limiting acts, then this will be static. Here if limiting acts, then definitely what will happen here? This will be more than limiting, not possible. So the rod will slide down. So therefore, we have to assume here to be limiting, here to be static here. So from this, so what we can write here, no? F1 plus F2 should be equal to mg, and F1 is equal to F2. So F2 plus F2, so 2F2 equal to mg. So what is F2? F2 will be mu F naught. M what you can write, rho AL into G. How to bring F naught? How to bring F naught? I think I'll go for thermal stress Young's modulus equal to F naught by A delta L by L. So what is F naught? YL Y delta YA delta L by L. What is delta L? L alpha delta theta. So YA alpha delta theta. This is F. So I'll substitute here, no? YA alpha delta theta equal to rho A L G. A get cancels. So this will become rho L G by 2 mu Y alpha. So what is the concept? Here, if they are limiting, the other friction should be static because 2 mu is there. So even thermal expansion friction ideas will bring it. Whatever we want, we can introduce, no? There's no limit. Huh? Delta T is what? Change in temperature. No, if I increase temperature more than this, here slipping will occur and the rod cannot be in equilibrium. Are you able to understand? If I rise the temperature, if I increase temperature more than delta T, where slipping will occur? At the right wall, at here, this one.